All right, now we're good to go. So, Ali and Aya, how are you? Najaf, Rabia, what's up?
Good, sir. How are you?
Okay, so I'm gonna start off with electromagnetism today. All right, this is like one of the most important chapters that we have here. So, the first thing we're gonna do in this is the part where we're gonna learn about force on a current carrying conductor. So, what you guys need to understand is that usually when current is moving, of course, it basically builds a magnetic field around it. So, suppose you have a plane like this, and while I'm doing this, I want everybody to be very attentive and follow what I'm saying. And a wire is like going through. So this is a 3D drawing. So let's suppose the current is going like from top to bottom, like bottom to top. So this current will basically have a magnetic field around it. And how do we know where this magnetic field lies? We can basically use a rule which is called the right hand grip rule. Now, right hand grip rule works for number one. Let's talk about this as when there is a single wire. When there is a single wire, then the right hand grip rule is like, you know, your hand, your thumb basically points towards the direction of current, and if you use your right hand, your fingers would basically look like this. Okay, you can try this. So what you guys need to understand is that the thumb will show you the direction of current, and the fingers curl in the direction of magnetic field. Now, the curl that's happening right now, like when you open your hand, it would look like something like that, right? Okay, I've made extra long fingers, but it's all right. So it will look like this. This is your palm, right? And when you close it, they're gonna turn this way, and it's gonna be like this. Is it happening like that? Everyone, please try this. Okay. Is it working or no?
Yes, sir.
Okay.
Yes, sir.
This would mean
Yes, sir.
yes. Okay. So this would mean that basically the field is going in circles like this. And this direction is a clockwise direction like that. All right. These circles will be concentric. So I'm going to write concentric circles. Concentric circles mean that basically each circle will be bigger than the prior one. So they're going to outgrow like this each other, right? So minimum in the exam, when they ask you to draw this, minimum you need to draw at least 3 of them. All right, so I'm going to also write this note. At least 3 circles are needed in the exam. So you should remember that. Okay. Now, if you want to make a 2D drawing of this, so it would look like this. So if you're looking from the top, you should remember that the current is basically coming out, and when current is coming towards you, it means that it will be a dot, because the dot basically shows out of page, and if there is a cross and circle, it shows into the page. Now if you're looking at from the top, of course the current is going towards you, that's why I made a dot. And now the field would look like this. You can obviously draw concentric circles freehand, but make sure that they have the right arrows and they're bigger like this. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right, you can draw this, please, and then we'll move forward. Shawis, how are you doing today? Zarish? Zen? Okay. Right. Interesting.
Sir, I'm done.
Okay. Now, then let's go to the next part. Now, this could also happen that now you guys might see that the current is going in the opposite direction, which means it's going from top to bottom, like that. Now, if it's going from top to bottom, again, your thumb should be downwards. So if your thumb is downwards, like this, then you would see that your fingers will basically curl from the other side. Is it clear, everybody? Like that.
Yes, sir.
Okay. So your fingers will curl from the other side, which means that now it's going this way, like it's turning this way, it's clockwise. So now you can draw the field like this, clockwise. Every circle bigger than before, like that. So the field would look like this. And if you happen to draw the 2D figure, so if you're looking from the top view, then basically the current is going into the page, which means that there will be a cross and there will be circle, and now it's going like this. Uh-oh, my bad. So something like this, clockwise. Alright, if you have any questions now, please go ahead, ask me. Fahad, are you understanding this?
Yes, sir.
Okay. So, what we've learned is, right now, we've learned when a current carrying wire is placed, it causes a magnetic field to be generated around it. that's what we're looking at right now. Okay. Now, so now let's look at what happens if there are two wires, not a single one. So suppose there is one wire which is going like this. Wait a second, please. And then there's another wire which is going like this. It's carrying current up and down. Now, from the right hand rule, grip rule, we already know by using that thumb up, curl, thumb down, curl. So this field is gonna look like the anti-clockwise one. And then this one is gonna look like clockwise one, as we've done already. And now, if you notice very closely here, you'll see that the direction of the arrows at the very center right here, so in front of it, they're all the same. They're like in the same direction, right? So these two fields at the very center, this is where I'm talking about, right here. At the very center, they're basically the same, which means that these are like fields, and when like fields basically come together, they, wait, I need to remove the highlighter. So they will basically repel because they're like fields. Okay, so we're gonna write current carrying wires in opposite direction repel as they create like field, like magnetic field at the center. That's important. All right, everybody understands this?
Yes, sir.
You can also draw a 2D drawing now. Say, okay, let's do a 2D one. So here, one of them is like taking out of the page, the other one is going into the page, and now this one is like anti-clockwise. Okay, I should draw it a little bit less. And this one is like, okay, let me make this sure the color is the same. I have space issues going on. Okay. So here it would be like this, anti-clockwise. Here it would be clockwise. They're gonna repel. All right. Usually, what the examiners do is that they tend to remove these lines and then they just show that okay, they can extend like that. So that's also very similar. It doesn't really matter. All right. Is it clear, everyone? Any questions now?
No, sir, not from my side. No.
Okay. Very good. Very good. Very good. Moiz, are you getting everything?
Yes, sir.
Okay. Yusra, any questions? Okay. Now, so then, what if the wires are such that sometimes and it fails. Okay. So wires are like this. So one of them is like taking current up, and the other one is also taking current up. I mean the same direction, up or down, doesn't matter. Okay. Now again, when you use the grip rule, this one will cause it to go anti-clockwise, also anti-clockwise, also anti-clockwise. Okay. The other one is also anti-clockwise. Now, if you look at the center right here, you'd realize that basically this field has this direction and this field has this direction with circular, right? Now, at the very center right here, because the fields are opposite in direction, it means that unlike fields always attract. So this is going to cause the wires to twitch a bit because they're going to attract. Now, so we learned that current carrying wires in same direction attract as they create like unlike, sorry. They create unlike magnetic field at the center. Alright. Now if you create a 2D drawing, okay, so the 2D drawing would be like this, because now the current is going out, so we're going to draw dot and dot circle with that. So the green field was like this. And the blue one was like this too. Okay, and their directions were anti-clockwise. So they repel. Now, just a final touch here. Because these fields are like unlike, so just to give you a bit of sprinkler here, they also connect with each other. Like what? Okay, let's use pink. So they connect in a flow. So they connect like this in the same flow that it is. Same goes for this one. That's just an extra touch, Alright, is it clear, everyone?
Yes, sir.
Okay, you can copy this, please. Okay. Is that clear? Everything is clear? Should I go forward then?
Yes, sir.
Cool. Okay.
Yes.
That's perfect. So then, what you're going to do is we're going to learn about something called solenoid. We're going to learn how field of a solenoid is created. Okay. So a solenoid is basically a coiled up wire. So when you coil up a wire, it looks like this. And then you can of course connect it to positive or a negative terminal because you want flow current. And now when the current goes from positive, it comes back like this, like that, like that, like that, like that, and then it goes like this. Okay. Now what you're going to do is you're also going to use the right hand grip rule in this. But this time, right hand grip rule, the fingers curl will show you the current and the thumb shows you the north. That's very important. Okay, now let me tell you how. So right now, if you try to grip it like using your right hand, so your fingers would be like this, all right, and then your thumb would be like this. You can try this as well. Is it happening? Can you try with your right hand? So you notice that these are your fingernails, okay? So the fingers are basically in the same direction as the current and thumb is pointing towards the right. Is that true?
Yes, sir.
Okay.
Yes, sir.
Which means that now north is going to be created on this side and south will be created on this side because this direction is where the north will be. Okay. Now if you want to create the field will be like this. Out from the north and in from the south. And of course the field is going to connect inside like this. Alright. And you can connect it from the outside as well, doesn't matter. Is it clear, everyone? Will you be able to do it in the
Yes,
exam?
sir.
Yeah. Okay. So always remember that. So right hand grip rule is for single wire and the solenoid, but it has different rules each time. So you got to remember this, and that's very important. Okay. Zainab, everything is clear?
Yes, sir.
Good. Okay. So in 8 minutes, when the meeting closes, you guys need to rejoin. Okay. Just a reminder, same link. Now, since we're done with this, so we're gonna go to the next thing, which is basically DC motor. And before we go into DC motor, I would just like to explain to you something called Fleming's left hand rule. Now, so I would like to take help from the internet right now, and of course you need to practice it right now. Oh my god, my typing so bad. Okay, so let's copy this. Okay. All right. Now, so in Fleming's left hand rule, you should be, of course, using left hand. It should be made like this. Can you move your hand like this, please? You guys can do it, right? So remember that your index finger basically shows you the direction of magnetic field, and the direction of magnetic field is always from north to south. This is the middle one. The middle finger shows you the current direction, and this current direction is always like from going from positive to negative. You need to remember that. And the thumb shows you the direction of force. Is that clear?
Yes, sir.
Now, let's try on something, okay? So suppose that we got north and we got south, like that, and there is a wire that is carrying current this way. All right, now naturally you should remember that the direction of field is from north to south, like this, right? So you always want to place index finger first. So if you place the index finger, it's gonna be towards the south. Can you do that? Then you align middle finger without moving index finger. So when you align it, so now right now you should have like middle finger like this, index finger like that. Is that happening?
Yes, sir.
And then you'd notice that the thumb is on the top, like upwards to the ceiling, right? That would mean that this wire will feel a force upwards. Is it clear? Any questions?
Yes, sir.
Okay. Now let's do the other one, and then I'm gonna ask one of you what you find. So you got north, and of course you got south, but this time it's gonna be like this. The current is going inside the screen. Okay, so can you guys please tell me where the force might be? I would like to know it from Zen. Yes, Zen, can you please try? Zen.
Can you hear me?
Now I can.
What was the question?
Yes. I want you to tell me where the force might be.
From north to south, no?
What? Okay, that's not north, south, no. Rabia. Rabia, can you please tell me where the force might be?
Sir, I think after the arrow on the front.
On the front. Okay, no. Alright, I want to ask Zainab then. Zainab, can you please tell me where the force might be?
Sir, what did you say?
Where the force would be on this wire, like going current, like taking current.
Downwards.
Downwards. Okay. Alright, so there's less than a minute. All of you who have not done it yet, I just want to tell you. First align your index finger towards the south. Once you've done it, then you want to align your middle finger towards the current. How do you do that? So if this is the shape of your hand, you're gonna turn your wrist. You can twist your wrist like this. Like don't like turn it, don't twist it. Okay, turn it like this, so that index finger remains the same place towards the right, but your middle finger. Okay, so I was saying that index finger is towards the south, but the middle finger should be such that it is going towards the current. So it should be pointing towards the screen you're looking at right now. And then your thumb should be pointing down. Is that correct, Zan? Zan has not joined yet. Okay. Okay. Zarish, do you understand this?
Yes, sir.
So this means that now this force should be, the force must be downwards, right? Okay. Fahad, do you understand this? Yusra? Najib?
Yes, sir.
Okay. That's very, very good, actually. Okay. So now keeping that in mind, what we are going to do now, it's only like 10 minutes left, so we're gonna quickly draw the drawing of the motor, and then we're going to continue it tomorrow. Like tomorrow we have class, right? No, next week. Okay, so in a motor we have permanent magnets like these, and then we should draw it bigger. like this, and then you're gonna draw two rings like this. Okay, I think I should draw it in a different color though. Oh crap. Let me use, what color do I use? Okay, purple would be it then. Okay, like that. And then you guys need to draw this and this, and now label this. So this is basically the permanent magnet. This is the rotating coil. This is the, okay, that's permanent magnet as well. These two are called split ring commutator. This is carbon brush. There are two of them, and then positive and negative terminal that you need to draw. All right, so please draw this quickly and also label it, because usually drawing is not so important, but the labeling is very important because they can ask you what exactly these things are. Okay. Okay. Now at this position, let's call this point A, side A and side B, like that. All right. All right, you guys done? All right. Now in the next class, we're going to discuss this because I want a full class on this. And I want you to draw this like, in fact, you can keep it like this, then we'll discuss it, don't worry. Okay. So if you have any questions that you still have anything that you did not get, please let me know. So I'm gonna see you people in the next class then. Have a nice weekend. Bye.
Okay, sir. Thank you.